See, before we get into this detail of any of these protocols, you have to get the philosophy right. Okay. Why we want these protocols? Already there are so many protocols that are there internet in the internet world, right. You have HTTP, which is an application protocol, very popular protocol that we have all been using. Essentially browsers are HTTP clients, right, and so that protocol already exists. For moving files, bulk file transfers, for bulk file movements, you have FTP, and the secure version of FTP is the SFTP, that is another protocol. So like that there are so many protocols which are around. Why one more? Why not adapt existing ones and use them? Why create many more? That may be one thing that may be bothering you. So we have to understand that part first. That is one thing. Second thing is, there is one critical thing that you have to note in the IoT world. That is the reason why these protocols are required. Gone are the days where human action or human triggered events was generating traffic on the internet. It is gone. It is the machines which are going to generate a lot of traffic. It is the machines which are going to consume a lot of traffic. Okay, so data sources and data sinks are essentially machines here. Therefore, the existing protocols are not suitable to ensure that securely data can be transferred from point A to point B without the human in the loop. Many times it is good not to have human in the loop, and you know, I just recently read a article, I am sure you might have seen that in the newspapers as well, that you know, all these voice based command systems are quite popular, right. You have Siri for instance from Apple, then you have products from Amazon called Amazon Echo, which is from Amazon. Then there are so many other vendors which provide you solutions where essentially you can talk to that device and the device will find out, get you information, and perhaps tell you about weather, tell you about cooking recipes and so on and so forth. So many nice things it does. Essentially everything is around voice recognition, speech and all of that. So a lot of IoT products in that space. There is also this thing about such devices which use lot of learning mechanisms behind, and it is a very intelligent device ultimately, right, because it is able to recognize, able to differentiate between different voices and take commands, and yet able to you know, carry out the activity, carry out the command that has been issued by the owner of the device. All this is good, but there is also you know, all this being you know, sort of being trained. Amazon Echo, let us put them down. Echo is one such device, Amazon Echo. Then you have Siri, which is actually integrated into many phone products, but I gather they will also have a standalone device, and so on. So many other devices which seem to be coming up, essentially based on voice recognition, commands which are based on voice and so on. Recall I mentioned to you about single word proper recognition, command recognition kind of algorithms, particularly this dynamic time warping algorithm which I mentioned to you when we were discussing about the space on vibration energy harvesting. I mentioned that DTW is something that is a nicely used algorithm. Anyway, that apart, the nice thing about these products is sometimes they are unable to differentiate by a command issued by, let us say, a human in front of it, or even a television which is just speaking out a command, right. So that is a real problem. For example, if it is there is a television serial in which you are watching and Echo is tuned to call a 911 number, for instance, if something like call the police comes up, right, then what will happen? If it is really, it does not know that it is actually coming from a television, part of a television serial, and actually it calls the police. It really turns out that many times you can have this kind of false problems with these kind of devices, because they are little bit dumb in that sense. So it so happened recently that there was a fight in a house, and then so it just happened that during the course of the fight the device that was there actually heard sort of call the sheriff or call the police or something like this, and in fact the people actually landed right in time, came back in time to sort of ensure that the fight was avoided in the house. So such good things also can happen with so do you call this a bug on such devices, or do you call it like a feature, is often a thin line, right. So if it works in your favor, if it works in favor of the human, obviously it is a nice feature. Anyway, all of this clearly indicates that a machine was actually collecting data, interpreting, understanding, having intelligence and calling out help and support outside. So it was actually, there was a consumer which was also a machine perhaps, which alerted the police out there, and which asked them to call back. So a machine really received the data, a machine transmitted data and so on. So the protocols in the IoT world will have to cater to this is the key requirement. Therefore before we get into the details of any one of these protocols, what are those basic requirements that these IoT systems will have to support, you have to know correctly. I will put down one by one, and I think this is not an exhaustive list, but this is just to motivate you before we get into any protocol discussion, because protocol is, there is a standard, you understand the standard very well, there is perhaps an RFC which you read thoroughly, understand the nitty-gritties of the RFC, and then you do a implementation of the RFC, you get a protocol in place, right. Of course designing the protocol is one part, but then testing the protocol, conformance of the protocol is another story, which are all basically to harden the basic protocol in place, to weed out bugs, for instance, to ensure the correctness of operation of these protocols, to ensure that the expected operation actually happens. All that means looking at the conformance, then looking at vulnerabilities in the protocol, where are the holes in the protocol, what are exploits which because security has to go hand in hand when you talk about IoT. So security exploits, vulnerabilities and security exploits which the protocol has are all to be all have to be tested. Therefore you may have to do some sort of protocol fuzzing, for instance, trying out many test cases, fuzzing, or even looking at very specific exploits, critical exploits which will put holes into the protocol stack. All that will have to be done. So they are all another bullet, I would say, another large body of activity in the IoT world when you want to do. We will not get into that detail because in this limited time we have to understand the basic protocol first, quickly get into a demo, understand how you can use this protocol, because ultimate objective is, can I use this protocol as it is by following this course and building a system around it very quickly, right. So that is what you must ultimately aim at. So before I actually get into the protocol, let me put down a few points, I would say a few requirements. So I will take a fresh page and I will start with the requirements. So I will say IoT requirements. I will really I am using this because of lack of any better word, but if you do think that there is a better word, please do it. First thing is, there should be dynamic, any IoT system that you design should be dynamic and self adapting, okay. Big bullet, big understanding, a big name on this, it is very simple, okay. What actually it means is the following. For example, you take a camera, okay, a surveillance camera. What does a surveillance camera do? So I will put down an example of a camera. What does a camera do? Camera essentially is let us say you take a surveillance camera or some camera which you have placed in front of your house. Essentially you want 24/7 monitoring of this camera, correct, which means 24/7 monitoring of this camera. Look at what happens. You have daylight, you have good sunlight during the day, and towards the evening the whole system becomes dark. You still need good pictures, you do not mind compromising on black and white pictures towards the evening, after it is after the sun comes down, or you may want to enhance the environment lighting so that the camera sensor is able to still take color pictures. So there is one important parameter called the lux, which we described already when we are looking at energy harvesting and photovoltaic systems and so on. So there will be a specification for the surveillance camera that you want to buy. I want to monitor under very low lux, right, that is the unit. So you people will say 0.001 lux is what my camera can provide. Another person will say I can only provide you 0.01 lux, things like that. So this is an important parameter to look at. The other parameter that you will be looking at before you buy this camera sensor is it should work day and night, okay. This is an I would say insufficient specification if you just go by all the confusing data sheets of buying a camera. You should ensure that there is for night there is IR illumination built in, right. So IR illumination is built into the system, so that if the light comes down, if the lux goes to a very small value, the IR camera, the IR illumination, IR LEDs let us say, typically you will have the camera and all around you will have IR LEDs around it, okay. Typically these are all the I mean I am just telling you one camera that I have seen. So this is the main lens, these are all the supporting LEDs which simply switch on moment they sense that the light is low. Go back and look at your definition, dynamic and self adapting. What is it doing? It is doing all of this. It is able to detect that the lux has come down and immediately it says I have to switch on the IR light, IR LED, so that the area under which I am doing surveillance monitoring, it is able to essentially illuminate, IR illuminate the system, so that at least black and white pictures can be taken by the camera. The third thing, that means the lens should basically remove the IR filter which you do not want in the day, right. In the day you do not want the IR light to come in because there is already sufficient light, and the visible light itself is good enough for the camera sensor to pick up the images, color images. And in the night, if you feel that the illumination is very poor and you are not able to provide equivalent of whatever white light, I mean I will be very careful because you can't beat the whole spectrum of light that the sun gives, right. Whatever artificial white light that you create is good enough for color pictures, that is also insufficient, then the camera has to switch to black and white, and therefore when it switches to black and white you need the IR illumination. So you actually want the system to have a motor remove the IR filter from the lens directly, okay. Either it should do that or keep the lens and switch on that artificial white light, so that these IR LEDs can be switched off or not used, and in fact the camera is working under normal in the night also it is working as though it is like a day camera, because there is sufficient let us say LED lighting, good amount of LED lighting covering a good spectrum such that the camera is able to move back to the color mode. All this means it should be able to do dynamic and self adapting. So this is a bullet essentially talking about that. You could also be talking about in the same camera system, because the camera, so what is a camera? The surveillance camera, essentially there is an optics, right, and then there is a CMOS or a CCD charge coupled device based sensor which is capturing the image, and then you have essentially image data, then you have video data, okay. You have a video stream coming, and that video stream has to be compressed, so that you may want to transmit over, you want to encode it in some way, and you want to compress, and then you want to transmit the compressed video on the network, alright. So I will say I will just put the camera sensor, this is a camera sensor equivalent, okay, it is not a full picture, but it is like a, this is the network, okay. So directly you are doing, let us say 30 frames per second, you are capturing 30 fps let us say, and you are using some compression scheme, encode and compressing scheme. It could be H dot one of the H dot 264 I think, yeah, 264 is a standard, or MPEG 4 systems, or any one of these standard compression schemes you want to use, and you want to send the data on to a central storage device, because you want to archive the video streams. But that is not going to, you can't be doing it all the time 24/7. You want to start this camera only when there is a human movement across it. So there are these motion triggered cameras. Essentially they will have a PIR sensor, and the PIR sensor will detect a motion, and once the motion starts the recording will start. It will do the compression, and then it will do a transmission on the network. Now assume that the network fails, right. So you need a local storage. Now camera has again got to adapt itself. It has to say, oh, I have sensed that the network is down, I must switch and put the data back on the local storage. How is that going to work? So there are features which you have to look for this camera, okay. I think it is called ANR feature. This particular aspect is also called, I am just giving you some normally used commercial terms, it is called automatic network recording or some, I forget the actual expansion, but please do look up that expansion on what this actually stands for. So there is a feature there, that is the key point. Again it emphasizes the fact that dynamic and self adapting is a very important feature, and this is a very good IoT product you can think of, very good IoT product. PIR sensors essentially are those elements, is basically a sensor which essentially has it is a differentially wired sensor. Essentially if it is, I think I mentioned this once to you, but just to sort of recap, it uses the concept in physics called pyroelectric effect, and essentially and very popularly it is also called the passive infrared sensor. PIR actually people use it as passive infrared sensor. Essentially it means this, that if there is a human, the human is emitting a lot of IR radiation all around all the time. If this IR radiation appears in front of the sensor, it says there is a human, I mean it says there is motion, it will not say it is human, it will simply say it is a human, there is a motion. Moment it senses that there is a motion, this camera will start the recording process. So camera recording, lot of research, lot of nice things are happening to use these simple PIR systems to essentially differentiate between the motion, whether the motion happened due to humans or whether due to other animals. Even if there is a dog which cuts the camera, it is going to start recording. So you do not want to get into that, you want to build an intelligent system, and it is worth investing some amount of time, energy and technical effort in order to build multiple PIR systems which can essentially use that as a signature for differentiating, use the multiple signals which are coming from these PIR systems for the purposes of recognizing whether it is a human or an animal which actually crossed the camera. If it is an animal, you do not start the recording, that means you have added additional intelligence into the camera, some amount of analytics as they call, video data analytics would mean it is the camera that caught the image. For ground truth, for instance, you can open the camera, look at the ground truth and then say, okay, this was a dog and therefore I am not going to do it, but the main sensing actually came from, let us say, PIR, right. So you have a set of PIR sensors from which some algorithm that runs on it, nice classifier for instance between animal and human, and that the classifier says I found that this is a dog, and now and it gives a trigger to the camera and says you go and check whether it is really a dog. Then you switch on the camera, you identify that this is you capture an image and you run a video analytics or a image analytics algorithm, find out that it is indeed a dog, and then say okay, if that is a dog I am not going to do any recording, I am going to save on the hard disk space here, hard disk space, and so on and so forth, which is a clear indicator that IoT does require all of this support of this dynamic and self adapting feature in order to actually if you want to make a system, this is a very important requirement. The second thing is self configuring, right. The second thing is self configuring. In other words, we talk about software updates and adjusting the duty cycle, adjusting the duty cycle for sensing, for communication, whatever. If it is doing some sensing, it should be able to, let us say, adjust its duty cycle. I will give you a very simple example. Let us say there is a sensor which is expected to monitor the temperature. Okay, so this is the temperature. I am just visually putting it down, and there is a band that you have associated. Okay, this is the band. Okay, you are saying, and this is the lower threshold and this is the upper threshold. Okay, this is the point where it is supposed to monitor. You are saying as long as the temperature is within this band, you sample every, let us say, 5 minutes. I am just putting down some examples, please. 5 minutes, and do it at low resolution. Do not do 16 bit, do not do 24 bit, do 8 bit, maybe even 6 bit, very low resolution, right, low resolution, and sampling time is very high, right, high sampling time. But when it starts moving either up or down, you want to be a little more aggressive, right. How will you do that unless you are self configuring? You should be able to change the duty cycle of your system such that it is able to monitor much more aggressively. The third thing is you are bound to live in a world where there has to be interoperability. So, I would put down interoperable communication is a must. Communication, let me complete this, okay, which means whatever be the vendor, whichever is the vendor, whoever is the vendor, with whatever protocol that he comes up with, he should be, the sensor should be able to talk to each other. There is no way by which you can say I am going to do only this and this is not going to work. If you do a closed standard, you are bound to that vendor, right, for any further improvements or anything, and it may just turn out that that vendor simply closes down and closes shop and then goes away. You are stuck with all the equipment that you bought from that vendor. It is not going to work. So, you are going to, I mean, it is hard to to have success and scalability with that kind of thing. Therefore, you may want to look at interoperable communication. The fourth thing is unique identity, right. This is like your Aadhaar card, one number which is unique to you, right. That is possible in the world of IoT only if you have IP stack, and just not IP stack, it has to be IPv6 only, and you can't have a full blown IPv6 stack on a small constrained device, IoT device, where memory is a constraint, size is a constraint, you want to improve lifetimes, yet you want IPv6. Therefore, you must put constrained IPv6, and if you are using MAC layer protocols such as ZigBee, MAC layer protocols such as ZigBee and so on, they actually support a protocol called 6LoWPAN. 6LoWPAN. 6 stands for IPv6, low power personal area network. Okay. So, you must be looking at unique identity, not IPv4 anymore, but indeed IPv6. Okay. I have struck it off, but I will be a bit more generous because we use this quite a bit also even now. In fact, lot of it is we are all comfortable with IPv4 and it is restricted to private IP. Either it is the 10.xx.xx.xx range in the classical subnet based systems, or it is the 192.168 if it is the class B. This is class A, this is class B, or I think there is one more 168 is also there, I think. Anyway, this is class A and this is class B. So, it could be the private IPv4 in the case of IP, and in the IPv6 is indeed it has to be IPv6, and if it is constrained environment it has to be, and if you are using ZigBee kind of modes or ZigBee kind of devices for all your sensing and communication protocols, then it has to be 6LoWPAN. Alright. Then the other thing is related to let us say the fifth one. The fifth one indeed is related to integrated, this is important, integrated into information network. Remember what we are saying, this is all about information network. You take the whole thing, we are actually talking about information network systems, right. It is just not about doing things smart, it is not about a smart node, it is about collective intelligence really. There is this topic of smart and intelligent are often it is a very subjective thing, but in my view they are different. This is more to do with thinking, right. You have to deeply think on for a new scenario, thinking for a scenario which you have not encountered earlier, right. So, that is something that means you need intelligence there, but smartness is doing things autonomously and taking care of a few things, programmed things, and bringing in a lot of aspects of doing, I would say more you say, if you say you are a smart sensor, which means you can do many things on your own, you autonomously sense, you do all of what we discussed even with respect to the let us say the camera sensor I mentioned to you, it is doing a lot of things by itself. But really intelligence is the fact that a camera sensor caught something, the camera system that we discussed caught something which it did not know earlier. How does it react to that situation? That will be perhaps much higher order, and that would perhaps mean it is a really very good intelligent system. In the IoT world, I would say that it is very hard to achieve that by a single entity. It has to be a collective set of nodes which ultimately lead you to give you this collective intelligence, because the scenarios that emerge when you talk about a collection of nodes towards getting to achieve something can actually add to the overall collective intelligence of the system. Therefore, it now boils down to building intelligent systems or IoT systems, not just which are dumb in terms of being, I mean in fact smartness is one part, is going a little more than being dumb, but being a lot more intelligence means a collection of devices collectively which are able to do intelligently intelligently able to meet the required goal, right. Now this is the motivation, okay. Very small devices, smart devices, no problem, but at some point in time these smart devices, while they are very smart, may not have may not be able to achieve a bigger goal of being collectively very intelligent. They are not intelligent. So therefore you need to get all pieces of data collected by each one of these nodes in a transparent manner, and together they will perhaps provide a collective intelligence. Together they are able to do a few things, together they are able to achieve things of the required goal. Let us see a demonstration of this system in small bits and pieces with a small introduction to the first IoT protocol, which is called MQTT, message queue telemetry transfer. Let me give you some story before we go for the demo. This is basically a very lightweighted, sorry, this is to rub it out, lightweight, oops, WEIGHT, lightweighted messaging protocol. It is based on a very important paradigm. I think you must spend enough time in understanding the philosophy of this. This is called publish subscribe. It speaks volumes about this whole protocol. It is definitely client server, there is no problem, and I would say very importantly well suited for small IoT networks. So design for IoT means, design means choices. Should I use MQTT or should I use something else? You will come to this point at some point of time in time. Well, you are the best judge. You have to look at that famous word I keep saying, it depends, right. So you can't be saying it depends, but you have to actually analyze the ground reality. What is it that you want to achieve, and use that as an input towards choice of whether it should be MQTT or whether it should be another IoT protocol. Quickly let me summarize. The other one is indeed the constrained application protocol called the CoAP, right. Should it be this or should it be this? Well, we will see as it goes, but I can tell you this is my take on the system. If you are it is well suited, I would say, for small IoT network. You want to start something quickly, you want to finish off, and you want to test your system thoroughly. You do not want to look at any scaling at the moment. You still want to use publish subscribe framework architecture. Please use MQTT, message queue telemetry transfer. We have to get into the details of this, right. That is one part of the story. Now how does it suit the way by which we have been discussing about this important requirement of integrated into the information network is the key, right. Obviously we put down all these basic requirements, so somehow it should get integrated. Now let me put back this, how this architecture is good. Basically before you get into this architecture, what are the options that you have to put down, okay. For integration architecture, I would say you have independent applications. Basically you have independent applications, okay, in the one on the one side, and you want an integration architecture. You need an architecture, this is what you want, this is your goal, and you have sensor nodes, each one independently monitoring something or the other, and it is doing itself, right. It can be doing things smartly, no problem, but you want an integration architecture because you believe in collective intelligence. We believe in collective intelligence. How does this MQTT fit in? Before we do that, look at it this way. You have different ways of getting to this integration. One is you use a bus based architecture. You use a bus essentially, right. You have 1 to n nodes, and these 1 to n nodes essentially are able to send data, are able to communicate amongst themselves using this network bus. It is a common bus. This is one way. The second way is you do it with one middle entity and you have entities which are connected to it, right. I will say 1, this is some 10, let us say, this is something, and this is finally n. So, the same n that is here is now going through this middle entity. This middle entity is actually called the broker. Now, you have nodes which publish and there are nodes which subscribe to this. Nodes publish on a topic, nodes subscribe to the topic and get their data. So, you have publish and you have subscribe, that is why it is called the publish subscribe architecture. This is called a broker. These are clients, client, this is a client, client 1, and it goes on like this. So, can a client, you may ask questions like, can a client be both publish and subscribe, can it do both? Yes, why not? They can be publish, they can be publishing and they can also subscribe. They can be subscribing to another topic, this is topic 1, and who initiates the topic, who holds the topic, everything is held in the broker. Okay. So, broker, you can see this topic is strange, right, it is written as topic, but indeed this topic is nothing but the routing key itself, it is like a route. If there is a node n who does not want temperature, he will simply not subscribe to it. So, there is no subscription, there is no subscription to it. But if this node is also sending out pressure, he may want to subscribe to it. So, pressure information goes in this direction, pressure data, but temperature data will perhaps not go, although it is coming from the same node. So, very intelligently you route the data based on the topic. So, topic is like a route. So, I will say topic in very simple terms, it is also the routing key. Okay. So, that is the key thing, and this MQTT actually uses this. But you need to complete the story, right. You said independent applications, integration architecture for collective intelligence. The first type is a bus, the second is a publish subscribe architecture. What is the third? Well, third is pretty straightforward. Nodes we are denoting as this rectangular block. So, I will continue to use rectangular. You can do 1 to 1. Right, 1, some 10, and this is n. You go on establishing 1 to 1 connections. Here it is obvious, this node knows to whom he is sending, he knows to whom he is communicating, both ways. Here you do not need to know, they are disconnected. They are disconnected so well that this fellow may publish, this node may publish at a particular time, but this node may pick it up at a different time because of certain considerations. This node did not come up, therefore, it can pick up at some other time. Clearly it is an indication, it is an indicator that they are not connected with each other. You can have something similar to being connected or disconnected in the bus based architecture. It just puts out the data on the bus, whoever wants to pick up can pick it up, or it can also be that so okay. So the main difference between this bus based and the broker based is there is no central entity, right. You can see that the data is available right on the bus. So if you want to go meet this goal of integration architecture for collective intelligence for small networks without connecting the client to the subscriber and the publisher, but passing through a broker seems to work well for small networks. Let us see a demonstration of this MQTT and then come back and complete the discussion on MQTT, right. So if you recall, I was telling you all the basic requirements for IoTs, right, and we also mentioned that we took an example of one IoT protocol that we wanted to demonstrate. This is with respect to the camera example I started with. Okay. Now what we will do is we will try to connect everything with a very simple demonstration which basically will show you the power of this publish subscribe kind of paradigm communication model under which IoT devices can actually benefit from. Okay. So first thing is, so the big story goes like this, the demonstration goes like this. First is to see if one IoT node, okay, which has a sensor called a PIR sensor actually detects a motion, right. That means a human has entered or an animal has crossed or something, the sensor has actually detected it. So let us call this by the name topic in the MQTT, as I mentioned, is like a routing key. Let us give this a name for the topic as motion, okay, just a name called motion. Now the payload that should be contained in this topic, the message that goes out should say detected, alright. So let us see how we can first of all detect this motion, and then we can then see how this message can be published, right. Now there is so it should go where? It should go to the broker. I do not have a physical broker, and that is the beauty. I actually have the broker sitting on the cloud, and so we will assume that there is a cloud, and I will show you a small triangle which says it goes to the broker, and we can discuss these actual configurations in great detail as we go along, and how you can do this all by yourself with just simple mobile phones with you, and that should now be received by another sensor which says there is a motion detected, right. If the motion is detected, what should you do? You may want to switch on the camera to actually catch the face of the person on which you want to start either recording or use it for the purposes of authentication in case it is a door access system. That should be another sensor node. The other sensor node is only interested to know if there is a motion that is detected, and it will do its own processing. Go back to the original concept of collective intelligence we mentioned. So these nodes together are giving us a fantastic level of intelligence for our application. So now what we will do is we will shift you, let us now focus on the equipment and the simple board which Madhuri will demonstrate. So what she has done here is she has set up a PIR system, and she has shown a detection. You can see it is a very simple, very simple analog signal that you can get from this PIR sensor, and let us see if she can actually show you in real time if she can actually capture this signal if there is motion. So the way she is going to demonstrate this is she is going to wave her hand in front of this PIR sensor. She is going to show you where the sensor is, and then she is going to wave in front of it, and let us see what actually happens on the oscilloscope. Alright, so now that you can see now the detected captured waveform is reset. Now go ahead, where is the PIR sensor? That is the PIR. Can you use a pencil or something by which you can point to the PIR system? Okay, never mind. So yeah, that is fine. So that is the PIR sensor. The potentiometers are for what? The potentiometers that you see, these blue potentiometers are for adjusting the gain of the potentiometer,
Yes.
the gain of the PIR amplifier.
Yes,
So it is a 2-stage amplifier that you have here, and then both the stage gains are being adjusted.
Yes.
And you are powering this with a
9 volt.
9-volt battery. What the kind of current consumption for this sensor?
It is about 1 milliampere.
Roughly 1
Roughly
milliampere,
1.
including the electronics.
Yes,
Including the electronics. So you have a 2-stage op amp circuit,
Yes.
and then you are getting that signal. Can you now demonstrate to us
Yes.
the PIR system? Okay, very good, right. So you can see that, can you wave again, and you can hold the waveform.
Yes.
There was a waveform here. Maybe the time base can be reduced so that it is able to go faster. Yes. Even lower, even lower.
Even lower?
Yeah. No, so that you get the full. Yes, let us see now. Okay, good. Hold it. No, you do it again and hold it. Yes, hold it. Yes. So this is essentially a very small signal, and the voltage levels are very low. So in order to, so the trick in a PIR sensor essentially is not so much to do with the sensor, but really the optics that goes with it. So Madhuri will now demonstrate 3 different types of lenses that should be accompanied with any PIR system. The first one she has in her hand is a golf ball lens. As you can see, this is a lens which will allow the detection. And how will you place it on top? You place it on top of the lens system here, and then it is able to detect with almost 120-degree angle any motion that happens. So this is one type of lens. Supposing you now want, yes, it's fine. Supposing you now do not want such a high bandwidth, high beam width, you can actually go in for a spot lens. And what Madhuri has in her hand is a spot lens, which you will have to actually hold against it at its focal length.
Yes.
At its focal length, so that it is able to concentrate and give you a signal. So this is like reducing the beam width. Now another type of lens which essentially most people use, this is called a multi lens. What you can see here is hold against this, so that there will be the lines that the camera can capture. Yeah, you can see that the number of lines here, each line is like one detection. So if she is able to mount this against the PIR lens, and if she is able to hold it there, and if a human actually walks across, there will be multiple analog signals that appear here, which will essentially give her a which will give you a feel of the number of detections. You will actually get multiple detections, which will give you a nice sine wave as it moves from as the human crosses, or a body crosses from either left to right or right to left. As you can see, depending on the polarity of the signal, we will demonstrate that subsequently. You will be able to see whether it is the person has actually crossed from the left side to the right side, or from the right side to the left side. That direction is also possible, and the amplitude will actually tell you what kind of distance from the PIR actually the detection actually happened. So this is about the sensor. Now imagine that this information is now going on, is now captured into a publisher, right, who wants to take this data and push it to a broker. Okay, Abhirami is here, and she will show you with mobile phones how you can actually invoke a simple application on Android phones by which such a data, which is a topic referred to as motion and payload containing detect can actually be transmitted. Okay, so the app here is referred to as My MQTT, which you can download from Google Play, and you can see it is a very simple interface. There is a dashboard, there is a subscribe, there is a publish, and you can also see stored messages there, and there is a simple button for any specific tuning that you want to do. And see on top here very carefully, this publisher is actually contacting a broker, and you can see right on top the name of the broker. It is called broker.hivemq.com. Essentially this broker, which is a triangle here, is somewhere in the cloud, somewhere on the internet, there is no physical machine here, that is the beauty. Okay. So, physically you do not need to have any infrastructure, and if this phone has an internet connection, which most often phones with 3G, 4G actually are able to do, can actually transmit this message, which is essentially having a topic name as motion and carrying the name, the payload as detect. Okay. So, let us see how Abhirami is able to do that, and obviously there is a consumer for this data, right. You can see that you do not need humans to do that. That detection happens, it comes to this phone because it is interfaced. This is like a sensor node, you can imagine this to be like a sensor node, and let us see how automatically that message comes to the subscriber. Alright. So, all the configurations can be now shown on the subscriber. Alright. So, now Madhuri and Abhirami are here. Madhuri is in the role of a subscriber, and Abhirami is the is someone who needs the data. This is like one node and this is the other node, right. Now, the first step is that Madhuri will enter the name of the topic. The name of the topic is, as we said, it is motion. So, she will type motion and she will subscribe to that topic. What is the message that you see here? It is motion.
Yes.
Is there anything called detector or undetected?
No.
No. So, he is just waiting for any event that might happen
Yes.
through the PIR sensor, which is connected to this
Yes.
publisher, right. Now, she is about to send the topic name is motion, and the message itself is called detected, and she is about to publish that. You can see now she publishes and it says it has published the data here, and we should be able to see it here. You can see detected comes, right. This is a clear indicator that they are not connected physically, they are sending their messages independently to the MQTT broker, and the broker has the topic, and the information is held in data is held against the topic, is given out to all subscribers of that particular topic. It is like a routing. So, this machine has now received the data. Now, from here many interesting things can happen, right. What can happen is, this is the guy who got the information that there was a detection. He can issue back a message asking the system to either start recording or open the door access, and so on and so forth. We will see the remaining part of the protocol in its full architecture as we go along in the course.